the OS is really installed, it will be launched. And if you're again with DHCP, you do again a new request and get an address for your node. So you really have DHCP everywhere. If you really look at it, you have 3 DHCP interactions. One at the level of Pixie, iPixie client, one at the level of Ironic Python agent instance, and one on the level of the provision image. So with the solution that you have in MetalCube with an IPAM, you will get rid of the last one. And the question is how to get rid of the 2 first ones. So let's look also at how we get rid of the last one. It's by pushing IP addresses in the configuration of our server. So you build the drive that contains the cloud init configuration. So you've got a bare metal host with an operator to manage it. And you've got the cloud init, the base is the user data that is provided by your Bootstrap provider. But you have got also metadata that are provided in Metal 3 by Metal Cube data template. And so you've got a data template, and this kind refer to IP pools. And IP pools are the implementation on an IP address manager. In fact, there are 2 different kinds of implementation. One that is today more or less global to cluster API. And the first one that was really dedicated to MetalCube. And in the following, we'll mostly use the old one. So you've got the Metal 3 PAM with an IP pool. And when there's an IP claim, it replies with an IP address. And this IP address that is assigned in a range defined in the IP pool can then be used with a Metal 3 data template to build metadata in the sense of metadata for cloud init that will be expanded in the user data, or directly inside the network data. There is no kind of expansion. And you've got your CAPI provider that makes the links with your metadata, network data, user data, and from that you can really generate the config drive. It's something that we will want to do, but without cluster API at some point for the network configuration, without the DHCP, but with an PAM, when we will want to boot the Ironic Python agent with our bare metal host. There are some part of this schema that will be translated to that. So let's go back to booting servers. This time we will use virtual media instead of Pixie. And this will help us to remove the first call to DHCP. Instead of doing this DHCP request, we have Ironic that will tell the BMC through an already configured IP link. It's not magical. You still need the connection with the BMC to be established. It will tell it to expose a virtual drive that will contain the Ironic Python agent to the server. And so the server will boot from this drive instead of booting from the network. But as soon as you have installed this ironic Python agent, it needs to download the OS to do the introspection. It needs an IP address. And if you do not add anything more, it still needs to make a DHCP request to get this IP address. And then it works as before. And if you've got a cloud init with an IPAM, you can launch it, and you have already 2 of the DHCP requests that have disappeared, but we still have 1 last. So the solution is that this drive contains the IP address, and that we boot this ironic Python agent, and that it will look inside the drive to find an IP address. And if we do that, but we can completely operate without DHCP. And if you look only from the point of view of ironic, this problem is already solved because they already have the extensions to add what they call network data to the ironic Python agent image generated on the fly. And this network data can be used by modified ironic Python agent images to define the network configuration. So the format is an old OpenStack format. The tool to read this configuration is called Lean. It's a kind of lean cloud init, small cloud init. And part of the problem we will have now come from that it's try to do to work more or less like cloud init, whereas we have also a real cloud init that is working in our system. So if you look at a virtual media ISO generated by Ironic, you will find this structure. You've got a boot catalog that comes from the ISO 9600 specification. Then you've got your kernel and your init.rd that are the RAM disk and the kernel that you are starting, but they are started not directly, they are started through isolinux.bin for at least a BIOS version. In UEFI, it's a little different, but basically the same principle. And you've got isolinux.cfg, which contains the command line that is used, the boot command. So you've got the kernel, you've got where the and the parameter of this kernel, and it's very long because there's a lot of parameters linked to Ironic. Most of them are static, but you've got a set of callbacks and an agent token, and these are specific to your instance. So I prefer to warn you, Ironic agent token in some of the solution I will present, I will not be able to keep it, but it's not really mandatory for operating Ironic. And so the place where you find the network configuration for Glean is on this disk under a very weird path named as OpenStack latest and network data.json. And if the Ironic Python agent know where to find the disk, it's because it is labeled. And the label is config-2. Okay. So now we would like to use this feature of Ionic with the bare metal operator, and to use it, the patch is less than 40 lines of code. First, you must check if you want to use this feature or not. So either you use a flag or you use a fact that pre-provisioning image support is not enabled, but you have given a provisioning image to your host, and if that's the case, then the network data for Ionic Python agent that is given as a field in bare metal host, you have to pass it along to the point where you create the Ionic node, the Ionic representation of a server. And it's very easy to add then this network data because the library used inside the bare metal operator to interact with Ionic is a generic library that already supports those options from Ionic. It's good for code, and you just have to add this network data at the right place. So problem solved. Not completely, because with this patch you can start your node, inspect it, push an OS onto it, but then you cannot update it. And it looks strange, but the reason is that, as I've said, Ionic Python agent with Glean looks for a disk labeled config2, and Cloud Init does the same thing. And when you boot your server with real OS for the first time, you add a drive that is also named config2. So when you try to update your server, you've got the virtual media labeled config2, and you've got the config drive labeled config2 from the previous installation. And as you can expect, Ionic Python agent will take the wrong one, and you won't be able to update your server. So the solution is to change this config2 name used by Glean in whatever else you want. But to do that, you need to patch Glean to support alternate drive names. You need to patch the recipe for disk image builder, so the Ionic Python agent builder to set this alternate name, and then you need to modify the drive you build. You need to patch Ionic to use this new name, and you need to patch Ionic image in Metal Cube to so that you change this setting in the Ionic configuration. The first two tasks were already done by Ericsson Nordics on their Metal Cube DevOps tool, that are the tools that they are using for their CI. So from Ericsson pointing me to those modified Glean and modified disk image builder, and you have everything you need. The last two steps today in the experiment I made, I've done it directly on Ionic image, changing the code of Ionic, but it is just modifying Ionic and adding a new option. But that means that you have at least 4 projects to patch officially to have a full support of this solution. But if you look at Metal 3, you will see that the consider that the support is already existing, but by another way, another path. And this other path is that Ironic can also use externally prepared ISO for the Ironic Python agent. And they had developed this capability for Core OS that could not be booted with a standard Ironic Python agent. And the idea that this specifically crafted image can use a specific network configuration, and this is the role of this pre-provisioning network data name field that you have in bare metal host. I've reused it for what I've presented before, but the initial role of this field was to be used with this mechanism for pre-provisioner. And so when you boot a host, the bare metal host controller generates a custom resource, which is a pre-provisioning image that contains a pointer to this network data. And it adds some information on the format and the architecture expected. And the pre-provisioning image controller that you should implement must reply by modifying the status, and status will contain a URL for the generated ISO. This is what will be given through Redshift as a source for the drive. And the idea is that as long as this image exists, you should keep the custom resource exists, you should keep the image. And so the life cycle of your image is tied to the custom resource. So if you look at the code in the bare metal host controller, you will see that you have a template for doing such a controller. Most of the work we have done for using Lean and for renaming, for example, the drive can be reused, in fact. What you need to do if you want to use this path is to build the ISO, the same kind of ISO as Ironic is doing, but doing it externally and expose it through a server. Do not forget that for most BMC, as OS images are large, they really need to support HTTP ranges so that they can query the image by chunks. So if you expect to generate it on the fly when it is needed, it's a little tricky because of this use of HTTP range. If you look at the code of the provisioner for OpenShift, you will see that it's a very large project with a lot of code for providing the image. And one thing that is missing in some sense is that usually you do this image for host that is either in BIOS or UEFI. If you look at what Ironic does when you generate image, it's generating the image for the correct setting, but this setting is not given in the pre-provisioning image custom resource. So what they generate an image that support both UEFI and BIOS at the same time to circumvent this lack of parameter, lack of information. And I cannot conclude without giving a third approach, which is based on, again, the pre-provisioning image custom resource, but which is much simpler. If you can use this pre-provisioning image also for booting with a RAM disk and a kernel in a more traditional way. And in that case, you can add some kernel parameters to the command line that will be used. And that's what Dashif has done, is that they are modifying only the kernel parameters, so that all the network configuration is done through the command line for the kernel. But you must remember that it's very limited in size, so it's better suited for environment where you know what kind of parameter you change, and more or less you have an ironic Python agent that is tailored to your kind of infrastructure and just need some very small parameters. So I finished with the implementation, and I will go back to to the problem of automating the use of those network configuration. If you look at a typical example indeed of Glean configuration, you have something like that for each bare metal host. And you have at least to define the IP address and the Ethernet MAC address that identify your link. In fact, it's the boot MAC address that you have in the definition of your bare metal host. And the remainder is more or less always the same, except that usually the gateway and the DNS, you would like to keep them parameterized and coming probably from your IPAM. At least if you're using MetalCube IPAM, you can give those parameters in the definition of the IP pool. And this, as you need to do it for each of your hosts, you really want to define the IP address through an IP address manager and with an IP pool, and not by hand for each host. And the solution is to implement a new custom resource that is very similar to a MetalCube data template, but that is directly attached to the bare metal host before we even speak of booting a cluster. And for us, it's attached through an annotation that is the name of the PMH data. And this custom resource contains two things. It contains a template for the network data and the list of IP pools to use for generating IP address. And in fact, we are generating the secret for the pre-provisioning network data, but we can also use the same thing for generating user data or network data if we wanted to use our bare metal host for things that are not related to booting clusters. And the last thing is that you can also push the IP addresses that you have generated as annotations on the bare metal host. I will explain why later. There's one thing that you must keep in mind is that the pre-provisioning network data is really needed as soon as you have the bare metal host activated, because if you do not have it, you can really not correctly register your host, and clearly you cannot do introspection. But generating it from your IPAM and your templates takes time. So the solution is that when you declare a bare metal host, it should be paused with annotation bare metal host metalcube.io paused that is usually used for pivoting. And the value of this annotation should identify the controller that has the right to remove this annotation. So it can either be your BMS data controller if it is alone at the beginning, and it is the only one that needs to work before the system is launched, but it can also be other controllers that react when base data has added some annotations on the bare metal host. This can happen if you are also doing network reconfiguration. When you start host, you can have multiple sources of pre-configuration that need to be done before the bare metal host is declared as ready for inspection. And in fact, I will go back to the one little detail is that we add the IP address generated at level as annotations on the bare metal host, so that those IP addresses are finally assigned to a server, and there are contexts where you can reuse them in when you boot the cluster and you use the data template from MetalCube. Instead of calling again the IP address manager and generating a new address, you can use the address that is in those annotations, and you can avoid having two addresses for exactly the same interface, but just at different time in the life of the same server.
Do we take the questions on the fly, or do you want to? I see that Stephen is having a question, so.
Yeah, sorry, I wasn't sure if you wanted to get into questions now. Just I'm aware that we're going to be a bit limited on time. The question was, I wanted to firstly say thank you, Pierre. That was a really thorough explanation of the problem. And at SUSE, we've been doing very similar investigations and have reached some similar conclusions, and also encountered the same challenges. I was also part of the team in my previous role at Red Hat who implemented the image building solution. So I'm kind of aware of the pros and cons of that as well. I would agree with your analysis that is a relatively heavyweight solution, when in this case, I think all we really need is a disc label or another identifier to allow us to distinguish the old and the new image. But the main question I wanted to ask was why you went for a custom controller for the IPAM rather than extending the MetalCube data template. Because I've actually pushed and landed a bare metal operator PR, which I think is basically exactly the same as your bare metal operator patch. It's not yet released, but it should be soon, and we added it to the SUSE image already. But yeah, it was really the MetalCube data template part. I was planning to extend what exists in the MetalCube data template controller for the same reason, so we can do IPAM for the pre-provisioning network data. And I just wondered if you could explain your reasons for not going with that approach.
But the data template is in fact linked with a cluster. It's not linked with a bare metal host. And when you need it for the first introspection and at the beginning, you don't know in which cluster you will be. So that was a reason to have, I agree, something that is more or less the same thing as a data template, but that ignores the machine level. And but on the other hand, that is directly attached to the bare metal host and not attached to a cluster.
Yeah, that's a good point. The life cycle of the two resources is different. It sounds like we can perhaps collaborate, because I was planning to spend some time in the near future trying to figure out how we can get this exact same functionality landed upstream. As I mentioned, we've now got the bare metal operator change, which should allow us to rely on the ironic config drive image generation instead of having to build a new image pre-provisioning image controller. But yeah, the next step will be to figure out the templating part of it. So perhaps we can collaborate. I think it would be really nice if we can solve this in the upstream MetalCubed community. I think there have been a number of downstream related solutions to this, and it would be preferable, if possible, to avoid introducing another one.
Yeah, sure. All the code is available. For example, the BMH data is the last item. There's nothing specific about Canard in this code, except maybe some naming part, but for most of it, it's relatively generic. There are a few things probably to remove, because we are doing right now some experiment with bring your own host, and where we need to also inject things from inside our metadata. But apart from that, it's very generic. Maybe we can reuse a data template as is and attach it to bare metal host and pretend that we share the same structure at all the levels. But I'm not sure that it will be very clean, and I don't think we should completely forget the case where you use bare metal host without cluster API behind, because it can also be useful in some case to boot some bare metal host.
Is that a use case that we care about in Silver? Because obviously, if you want to use the MetalCubed IPAM controller, that's highly coupled to the MetalCube data template and the kind of machine abstractions. So I appreciate that there are use cases for bare metal host to be used independently, but I'm just wondering if in Silver we have that requirement.
I don't see this kind of requirement in the short term, but I think it would be really beneficial to have a pool of bare metal hosts that can be reused in separated clusters, because we deal with multiple clusters with Silva, and we'd like to avoid having some specific servers attached to a specific cluster. We'd like them to be available for a pool of clusters. So in the long term, it would be really beneficial to be able to do that.
I think there is two different questions. There is a capability to use a server on different clusters, which is one thing, and there's also the capability to use the server on something that is not a cluster. For example, you want to to boot a bunch of safe servers, but you do not
Okay.
configure them as a Kubernetes cluster. I must say that 2 years ago, I would have said that it was really something that we wanted to be able to do. Today, in some sense, there are cases where you create a cluster of bare metal hosts, not to use it as a Kubernetes cluster, but just as a way to have to see the state of those bare metal hosts and to have feedback on the OS of those bare metal hosts, even if those bare metal hosts will be used for something that is completely unrelated to Kubernetes. Kubernetes is more for
I mean, for inventory purposes?
Inventory and metrics and log collecting and things like that.
I mean, that is already possible if you have some other method of doing IPAM. So you could have, templated bare metal host resources and templated network data secrets and that kind of thing, which is actually exactly how I've been testing the bare metal operator PR. And so, I think there probably are users in the community who are using bare metal hosts in that way, but probably not leveraging the IPAM controller that is provided alongside CAPM3. The other open question, I think, is the agent that we use. So obviously, in the case of Cloud Init and Glean, they're both Python-based tools. And not all operating systems, particularly when we start looking at Leap Micro and other similar minimal immutable platforms, they don't always support Python out of the box. So I think that's another interesting question to explore as we kind of work out the details on this, is whether Glean and Cloud Init are the only options, or whether there are other first boot tools that we might want to consider using.
Yes, but on the other hand, it's a simplest solution on what can be considered today as standard OS without any kind of modification, and with a list. If you look at what is on the CNF market today, you often have old real-time OS and things like that where you're happy to be able to use Cloud Init and standard tooling. An ironic Python agent is a different problem, because more or less it's whatever you want as ironic Python agent.
Yeah, I think the
underlying OS is different.
Yeah, I mean, I think the main issue is, if you've got two different tools, one in the agent phase of the process and another on the operating system, particularly when you get into the more advanced network configuration scenarios, you're likely to run into situations where they don't necessarily behave the same, and potentially, you encounter bugs in one and not on the other. So, if there's a way to use the same tool in both places, I think that would be an advantage. But I don't see an easy way to do that right now, given the chain of dependencies it would take to, run the full Cloud Init in the IPA round disk.
Yeah.
So just to conclude here, I understand that we are sharing the strategy of patching upstream projects, but I wonder if it matches our roadmap, and especially our goal to get rid of this DHCP feature for the V1 beginning of next year. Are you confident in being able to have everything released in upstream project before the end of the year?
I think we need to have this discussion around the IPAM and templating in the upstream metal cubes community. So Pierre, perhaps I can loop you into that conversation and we can discuss the details. A few weeks ago, we discussed the bare metal operator aspect of this with folks from Red Hat and Ericsson who had previously worked on this problem. And we were able to, move fairly quickly in terms of landing that patch. So, and I think that kind of closes one gap which you've already worked around by patching the bare metal operator. I think we're just going to have to try and figure out how to reduce the number of downstream customizations, ideally to 0. So I think let's revisit this discussion in a couple of weeks' time once we've had that conversation. I mean, we know that we have the option, if necessary, of running a custom pre-provisioning image controller. We know that would solve this problem, but it's a fairly heavy solution, and I think it would be nice to explore the alternatives before we go down that path.
And what about the last solution of workarounding this issue by using kernel parameters? That it seems simplest.
It's not as easy as it looks because you still need to modify ironic Python agent to look at those kernel parameters and do the action for you. And you would probably need some ironic Python agent instance per really class of deployment. For example, if you have bonds or things like that, you may end up with something that you will not give through the kernel parameter, and you will have most of the configuration burnt into your ironic Python agent. We do not want to rebuild an ironic Python agent for each deployment.
Okay. We are running out of time. Is there any other question to Pierre or maybe to Steven or to anyone?
I was just curious, Steven, you had something else in mind? It's just my curiosity. You said maybe Python is not the best option.
Well, I think if you look in the community, there's a number of other options. For example, there's YIP and CoreOS Cloud Init, which are not Python based and therefore are a bit more lightweight in terms of dependencies. I think, for now we can assume Cloud Init and Gleam because, those are two tools that have been proven to work in this scenario. I think the big open question at this point is how we handle the IPAM and the templating. So we can revisit that discussion upstream as the next step.
Okay. So I think we have to conclude.
Yes.
As I understand, we are not a solution out of the shelf with kernel for the moment, and on the metal cube we need to work with the community and to align together if we want to explore more this approach.
Yes, definitely. We need to discuss with those upstream community and see how it goes.
And if we need some support of Ericsson to push, also it's possible we can help in this direction.
Yeah, sure. Do we have someone from Ericsson on the call today?
No, but I'm in touch with the head of open source at Ericsson. So if we need to onboard them.
Okay.
But Norbert is the first. Norbert and Riyad are the first point of contact.
Okay, let's close this call then. Thank you, Pierre, for the presentation.
Many thanks, Pierre.
Thank you, Pierre.
And Steven for the interaction.